Is it recording?
Yep.
Good. Right, so question 8 is this roots of polynomials one. And so we're going to have to work out, if we look at what we've got here, we've got alpha and beta and gamma involved in the thing there. We want to find the value of that in terms of k. Now as we start to think how we're going to begin this, I think it probably makes sense to write down some of the things we can get out of this equation. So the start point is, from that equation there, alpha plus beta plus gamma, well, the sum of the roots. Now remember, the sum of the roots is always, that's the one that we start with a minus, don't we? So that is minus 6 over k. The next one goes plus. So it always, do you remember, it always starts minus. That's the way to remember it. So the second term is the minus. The next one will be plus. So that's alpha beta plus beta gamma plus alpha gamma is 1 over k. And the last one, which actually turns out in this question we don't need, alpha beta gamma, that would then, so that's minus plus minus, so that would be 3 over k, because it's minus 3 over k, so it gives us plus 3 over k. It turns out we don't need that, but I've written them down for completeness. Right, I'm still kind of thinking around, trying to work out where to go with this. I look at this equation here and think, let's see what happens if I just multiply all that out and see what I'm aiming for. Because I'm thinking, if I do that, I'm going to end up with alpha beta and an alpha and a beta and a beta gamma. I'm going to end up with some of these things appearing. So let's see how that works. So, if we start investigating what happens with that, let's work that through. Multiplying out this first pair, we'd get alpha beta plus an alpha plus a beta. That's an alpha there. That's looking worse now. Plus a 1. 1 times 1, of course, is 1. Here I've got a beta gamma plus a beta plus gamma plus another 1. And at the end I've got a gamma alpha plus a gamma plus an alpha plus 1. And that's the whole thing, not particularly subtly, just multiplied out to see what happens. Now if I put these together into things that I know about, look, I've got alpha beta, beta gamma, and gamma alpha. That is those 3 terms collected together. And then look what else I'm left with. I've got alpha there, and there's an alpha over there as well. I've got beta there and there, and gamma there and there. So I've got 2 of each. Of alpha and beta and gamma. And I've also got 1, 2, 3 hanging around the end. Now in terms of what I started with, that bit is equal to 1 over k. That bit is equal to twice minus 6 over k. And that bit is equal to 3. Which gives me 1 over k, take away 12 over k, plus 3. And I wrote that's 3 minus 11 k. So that's a bit better. Just hang on before you pause it. The other way that you could have done that is, remember, you recognise that this is all to do with these roots are in the form alpha plus 1, or x plus 1. So we're going to replace, use the idea that they're in the form u plus 1 is equal to alpha. Our new root is u plus 1. So u is alpha minus 1. So we're going to substitute alpha minus 1, I've written that in a really odd way now, but we're going to substitute u minus 1 in effect into the equation and get k times u minus 1 cubed plus, what was it? 6 times u minus 1 squared plus u minus 1 minus 3 equals 0. Work your way through that, multiply everything out, collect together the like terms, and then look at the relevant bit. We want to get the whatever you end up with as your x coefficient in your final equation, and that is going to be the thing that we need. And it works to do it that way as well. And that's maths.